Hello and welcome to the Section 9 videos. We're talking common logs and natural logs. So up till this point, we have been talking about logs in general. What is a log? How does it work? How can you simplify it? How can you solve equations? And you might be thinking, when are we ever going to use this crap, right? Logs is actually one of the most applicable things in the world. A lot of natural substances follow a logarithmic decay, a logarithmic situation. Lots of businesses. I know I use businesses a lot, but it's true. Basically, anything that is going to start really, really fast and then level out is going to follow a logarithmic scale. So it's kind of interesting that we wait so long in the year to talk about it when it's actually one of the most common things used. Now, even more so, there is a certain log that is used so often it has actually been dropped, or it has actually dropped its base. Log base 10. So if we recall, what does this expression mean? Log 10 of, I don't know, 100. Log 10 of 100 says what power of 10 is going to get you 100? That is equal to 2. But log powers of 10 are used so often. For example, scientific notation, if you recall way back when, sometimes when you have really big numbers in science, they drop off the zeros. And instead of writing 2 billion, they write 2.0 times 10 to the ninth. And that would be 2 billion, right? So instead of doing, is that billion? Yeah, that's billion. Instead of using something like that, when solving stuff like this, log comes in a lot. You can see when you have lots of those powers here, we could write that as log 9 or log base 10, 9, right? We would have log 10 of 9. But it's so often used that honestly, they don't bother saying the 10 anymore. And so when I'm sorry, not log base 10, 9. Log base 10, like a billion, x equals 9. Right, because 9 is the exponent is the answer. But they've dropped the 10 is the point here. It's the common log. It's so common it gets its own name. It's also so common that it is now in the calculator. Why on earth would it need to be in the calculator? This is actually a pretty easy function, right? Log 100, second power. Log 1, 0, 0, 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 10 million. Well, if there's 7 zeros, the answer to that is the 7th power, right? And so it's a very easy function to calculate. So why on earth would we need it to be in the calculator? Well, there's a lot of numbers between these powers, right? There's log 10, and the next whole number would be log 100, but that is a lot of numbers in between. So what is log 87? That's a little harder to find. What power of 10 is going to give me 87? Little more complicated to find. And so it has been pre-programmed in your calculator for you. If we jump down to examples 1, we can look at these logs, none of which are super easy to solve, right? 437,000 is pretty close to a power of 10. It's got a lot of zeros in it, but it's not 1, 0, 0, 0, 0. So it's not actually, it's probably still going to be a decimal. But let's look at these guys and see if they make sense. Over on whatever calculator you prefer, I'm going to use Desmos. This first one here is log 327.1. So if we go here, log is not right here. I'm going to have to go into function to find the log button, or I could just type log. The computer is smart enough to punch that in and know what I'm talking about. It was 327.1. We get 2.51 as our answer. So 2.51, let's go 5. Remember to round correctly with these. You know, we have 5 and above, give a shove, 4 below, let it go. Does that make sense though? What are we saying here? We're saying what power of 10 gives us 327. Well, the second power of 10 is 100, so it's got to be bigger than that. The third power of 10 is 1,000. And since we're exponential and we're going to grow faster on the back half than we do on the front half, about 2.5, that makes sense. We've got 100 here, 1,000 there, here's 300, right? That makes sense. That makes sense. All right, cool. So 2.15. Sorry, I just wanted to make that dot. Let's do something bigger. Log of 437,000. So log 437,000. Don't ever put a parenthesis or a comma inside a calculator. It will not know what to do. We get 5.64. The next one is a 4, so I'm going to leave that as a 0. 5.6-ish. Does that make sense? Well, let's see. 10 to the 5th power is 10,000. No, 100,000, pardon me, is 100,000. 10 to the 6th power is a million. About halfway in between that? About halfway in between, 5.6. Makes sense, makes sense. All right, what if we go dramatically the other way? What if we go really, really small and we do log of 0.0615? What happens there? Log of 0.0615 was the number there. Ooh, fascinating. We get a negative 1.2111. We'll go 11. What does that mean? What does that mean? Well, log, so we see 10 to the 1st is already 10, so it can't be that. But we know that 10 to the 0 is still 1. That's still positive, still bigger than our number here. And so it couldn't have been a positive exponent that gave us that number, right? Because 10 to the 0 is already a positive number. So that doesn't make any sense. 10 to the, oops, pardon me, 10 to the negative 1, we get 0.1, which is still bigger. So yes, it's making sense. We're going down, we're getting that negative number, a little bit more than 1, and we are there at 0.0615. Okay, that also makes sense. The last one here, log of negative 5. Ooh, fascinating. Why on earth would a log of this log 10 of negative 5 not exist? Why is this undefined? Well, let's think about it. Let's rewrite this one here. We'll call it x maybe. Log, no, not log. So if we rewrite it as an exponent, that's 10 to the x is equal to negative 5. Oh, that's right. No power is ever going to take a positive number and make it negative, right? Because we're talking multiplication, division of itself, right? And you can't take positive numbers, multiply and divide positive numbers, and all of a sudden change your sign. That doesn't work. And so this is undefined, D and E. Okay, cool. So it looks like this log calculator is following our log rules as well. All right, let's talk about another one that is also very commonly used. It's called the natural log. So this is the common log, the first one we're talking about, because it's just so common. The natural log is more of that one you find in nature. Okay, and I think a really cool example of that, is something that you didn't know you were growing up with. This is actually the curve of an infant's growth chart. So if you zoom in over here on this little picture over here, this is for girls. There is one for boys as well. But when you grow, you follow a logarithmic function. When you start out, you're itty bitty baby, you got to grow very fast. You got to get up to at least 2-3 feet or you're probably not going to survive, right? But then after that, you can start to taper off. And so we see these logarithmic numbers. But that's not a standard log there. That looks a little, bent and curvy and stuff. So it's got to be following a very special number. That is a log of a very special number. It's about 2.17828818828 ... No one wanted to write that. So we pulled out another letter. This is log base E. Okay, so this is log base E of whatever you want to call it. But that is the number that humans grow by, a lot of trees grow by, a lot of nature grows by. Why an E? Well, the guy who invented it thought he was cool enough to get a number named after himself. So Euler, I don't care how you want to pronounce it, but that is where we get the E. We get the E from his name. And it represents the number 2.718 ... Think very similar to pi is 3.14159 ... right? This is a number, so the number E. Yeah, got to get used to that, right? But it's kind of cool. You grew up by the number E, which is very fascinating. All right, let's see. Since this is also so commonly used, they wanted to change it so they didn't have to type in log E every time. Now this was decided way back when it was like Latin times. So this is called the natural log. And so in either Latin or Old French, I can't remember which one, it is logarithma naturale, okay? And so that's why we see it as LN, natural log. So it's actually just a language barrier there, but it's ln is the natural log. That's the symbol we use instead of writing log base d. So we have two kind of special logs in that they are common and naturally found, but they follow all the same rules. So let's take a look at this ln guy in our calculator and make sure he follows all the rules. All right. So we've got ln of 0.5. Once again, there is a button for ln. It's chilling right next to log, okay, right down here. And I could use that button, or I could just type in the numbers. That's fine too. Or type in the letters, pardon me, ln, and it will know what to do. 0.5841 is a negative, and that is following the rules. We saw before, decimal answers have to come from negative exponents, right? And so the answer was negative 0.53, and we'll round to 8. Cool. All right. Does it follow the next one? Hey, there we go. Let's see. ln of 192.7. ln, whoops, helps if you spell right, of 192.7. Let's see. That's 5.261. Let's see. Is that following the rules? Well, remember, this is the log of e. E is about 2.7. So are we looking at 2.7 to the 5th power is 143, right? And that's a little bit more than 143. 192 is a little bit more than 143. So yeah, I think that's a good approximation of that exponent, right? Cool. Let's look at another one. 10.84. ln of 10.84. 2.383. Well, 2.7, aka e. We could even write e. It is smart enough to know what e is. E to the 7th power, not 7th, sorry, to 2nd power is about 7. Yeah, it's a little bit bigger. 10.84 is just a little bit bigger than that. And so 2.3 being a little bigger than that too, that makes sense. So you can kind of see that crisscross pattern there. All right, what happens when we do ln of e? Interesting. ln of e. Why would that be the case? Why is this equal to 1? So we've got ln of e. Well, if we go back to old school formatting, that would be the log e of e. Right, if you have the same base to the same argument, that's saying the same thing as what e to what power is itself. Right, okay, still got to be 1. So it looks like it's also following the properties of log, which is good. All right, so that's 2 of our most commonly used, most natural logs. They're so natural, they have buttons in the calculator, which is great. We can also use those buttons to solve other logs, as we will see in a future video. Right now, if you have any questions, reach out to your teacher. Otherwise, I will see you there.